It's an MCQ question. The question will appear very soon. Try the question first. Write down in your book, do it, and then let's see whether you can do the question or not. If you could get the answer, that's great. And still, just go through with the video explanation. You will learn something new. Right, let's do it now. Alright, let's read the question first. 7 resistors, each of 1 ohms, are connected as shown in the figure. The effective resistance between A and B. So current flows from A to B. I'm putting a cell here so you can easily see that current flows from A to B, right? So let's draw the flow of current. Current can flow in this direction easily, or it can go through in this way, or it can go through in this way. So we can assume current will travel through all the resistors, right? So they are asking us to find the effective resistance. To finding effective resistance, actually I'm going to look at a couple of things. So first thing, I need to find whether these resistors are series or parallel, right? Second option, let's see whether I can find whether these are series or parallel. I can only see this resistor and this resistor are in series, but other than that, actually other resistors I don't see them as parallel resistors. These resistors, actually I cannot tell whether these are series or parallel, because the current flows up to here, but after that it gets divided into 2 parts. So these 2 resistors are not in series. None of these are in series. Then I'm in trouble. I cannot go with number 1 option. These are not series or parallel, right? Let's work on with second option, is to find whether there's Wheaton bridge. Wheaton bridge, right? So Wheaton bridge, of course you know, if there are parallel resistors like this, and of course current has to travel, current has to flow in this direction, and there will be no current flow through this particular resistor if these ratios are, resistance of these ratios are equal, right? So these R3, R4, and this R2, R1 over R2 equals R3 over R4, yes, then there won't be any current flow from A to B, right? So but still I cannot find any Wheaton bridge here. If only current flow from this point A to this point, the point I am showing here, point C, let's say, then only I can remove this resistor as Wheaton bridge, but actually we cannot apply that here because current flow from A to B, right? So third option I'm going to have is find any symmetric. That means in symmetric positions, that means is there any points where potentials are equal? What I can say is, I can say from between A and B, I can say this is symmetric from this point. From this axis, it's equal from both sides. So it's symmetric. So here I can conclude potential at this point, this particular point, and potential at this point are equal. So what I can do is I can get these 2 resistors into half values and connect it up to here, right? So it's like this. Now see what I have done. So I have removed it from here and connected it to here, half of it, half of it. So the value of this resistor is half, 1 over 2, and this is also half. So this resistor and this resistor now are parallel, starting from same point, right? So I'm going to add it in parallel format. 1 over R1 plus 1 over R2 equals 1 over R parallel. So this is 2 over 1, and other one 1 over 1 equals 1 over R. So here I am getting 1 over R equals 3 over 1. So R becomes, take the reciprocal value, 1 over 3. So the total value of this is 1 over 3. Then I can say this particular resistor and the added resistor, this resistor is in series. So I can directly add them. So then 1 plus 1 over 3, that becomes 4 over 3. That's the total resistance of, right? Now we have the total resistance of this part, right? That is 4 over 3. So then we can add this part and this resistor in parallel mode. So it's 3 over 4 plus 1 over 1 equals 1 over R. So we get 4 over 7, 4 common denominator, 3 plus 4, 7. So 1 over R, we get R equals 4 over 7, right. So now we have the total resistance of, say, this part, right. So this path and this part, and this part, the total resistance are equal. So if this is 4 over 7, this part also 4 over 7. So these two are, we can tell directly, these two are in series, this part and this part, 4 over 7, 4 over 7. So total value we can conclude that 8 over 7 ohms. So it's the fourth answer, D, that's the answer, right. So these type of questions are actually common in couple of circuits. So what you can do is find similar type of questions